In the vast expanse of human history, few inventions have reshaped the world as profoundly as the wheel. Before its arrival, the burden of distance weighed heavily on early civilizations. Movement was limited, labor was exhausting, and transport was crude at best. Yet, through a remarkable blend of creativity and necessity, the idea of a circular object that could rotate on an axle emerged. An idea so simple and yet so revolutionary. It did not begin with transportation. Early uses of the wheel, as far back as 3500 BCE, were in the humble art of pottery. In Mesopotamia, ancient potters used rotating platforms to shape their clay, spinning the material into forms with speed and precision. This pottery wheel, primitive though it may seem, planted the seed for one of the most transformative leaps in technology the world would ever know. From that seed grew an idea that would soon roll across continents. The first wheeled carts changed how we carried goods, farmed our land, and connected our communities. The wheel enabled armies to move swiftly, merchants to travel far, and explorers to push the boundaries of the known world. Over the centuries, it evolved, splitting into spoked wheels, chariot wheels, and later, the precision-engineered gears of clockwork and industry. And yet, the wheel is more than a mechanical component. It is a symbol of movement, progress, and the unending cycle of innovation. You find it everywhere, from the cart of a street vendor in ancient Babylon to the intricate machines of the Industrial Revolution, from the bicycles of Victorian Europe to the rovers now rolling across the dusty plains of Mars. This audiobook is a journey through time, a story not just of wood and axle, but of human ingenuity. We will travel through ancient civilizations that first embraced the wheel, witness its transformation through wars and empires, and explore its critical role in science, industry, and digital technology. The wheel is proof that a simple idea, born in a workshop thousands of years ago, can turn the course of human history. Join us as we follow its path, from the mud-brick streets of Sumer to the fast lanes of the modern world. This is the story of the wheel, how it began, how it evolved, and how it never stopped turning. Long before the wheel was ever conceived, early humans roamed the landscapes of Africa, Asia, and Europe, learning to survive in harsh and unforgiving environments. These were societies of hunters and gatherers, nomadic tribes that moved with the seasons and the migrations of the animals they hunted. Their tools were simple: stones sharpened into blades, sticks used as digging tools, and transportation was limited to what could be carried on their backs or dragged across the ground. The idea of moving large loads was a constant challenge. To move a fallen tree or a heavy stone, early humans likely used logs as rollers, an instinctive innovation born from observation. Watching a round log roll down a hill or across uneven ground may have sparked one of the earliest recognitions of how circular motion could ease burden. But even with this intuitive approach, there were limits. Rolling logs worked on flat terrain, but they required constant repositioning and weren't fixed in place. The Neolithic era, beginning around 10,000 BCE, marked a transformative shift. Agriculture began to replace hunting and gathering, and permanent settlements emerged. People no longer wandered in search of food. They planted, harvested, and stored. With this newfound stability came the need to transport surplus crops, building materials, and water. Human and animal labor alone was inefficient. Necessity was beginning to demand invention. However, despite the evident need, the wheel was not an obvious solution. Crafting a true wheel required significant technological leaps: a perfectly round component, a central hole, and a fixed axle, all made with durable material and shaped with precision. Early tools and knowledge weren't quite ready. Before the wheel, sledges, flat-bottomed platforms dragged by animals, were commonly used. These worked especially well on snow or mud, reducing friction and improving control. But they still had serious limitations. The concept of rotation was present in other areas of Neolithic life. The idea of spinning, for example, was applied in the use of the hand spindle, used to twist fibers into thread. The potter's wheel, emerging around 3,500 BCE in Mesopotamia, was the first true application of rotational technology for craftsmanship. These wheels were heavy, solid wooden discs spun horizontally, allowing potters to shape symmetrical vessels with ease and speed. This application of rotation hinted at future possibilities. Yet, it's crucial to recognize that the wheel was not an inevitable invention. Many advanced civilizations, like the Inca of South America, never developed it for transport, despite having complex societies, roads, and even wheeled toys. The invention of the wheel depended not only on need, but on materials, culture, and a moment of innovation. In the end, the wheel did not arrive suddenly. It was the product of centuries of human observation, trial, and ingenuity. The moment when someone, perhaps in ancient Mesopotamia, drilled a hole through a circular wooden disc and fixed it to a rotating axle, was a turning point in every sense of the word. With that moment, the world would begin to roll, slowly at first, but with a momentum that has never stopped. Around 3,500 BCE, in the fertile cradle of Mesopotamia, a quiet revolution took place, one that would forever alter the course of human history. This region, nestled between the Tigris and Euphrates rivers, was already a hub of innovation. Its people had developed agriculture, irrigation systems, and early writing. But among the most important inventions to emerge from this land was something deceptively simple: the wheel. The first wheels were not designed for transport. Instead, they appeared as potter's wheels, thick, flat discs of stone or wood that rotated horizontally on a fixed base. This allowed artisans to shape clay vessels more efficiently and symmetrically, marking a major leap in craft and productivity. These potter's wheels were heavy and difficult to turn, but they introduced something new: the concept of continuous rotation around a central point. This concept, once discovered, would lay the groundwork for one of the greatest engineering advances in history. The challenge lay in transferring the idea of rotation from pottery to transport. Simply attaching a disc to the bottom of a box wouldn't work. A usable wheel for vehicles required a new understanding of mechanical dynamics. The solution was the axle, a central rod around which the wheel could rotate. But early axles were not separate from the wheels themselves. Instead, they were fixed together, causing the entire assembly to rotate as one. This made turning difficult and placed immense stress on the structure. Over time, innovation led to the creation of a fixed axle with independently rotating wheels, a configuration still used in carts, wagons, and even modern vehicles. Crafting such wheels required significant skill and technology. Timber had to be cut into perfectly rounded forms and fitted with precision into an axle hole. The wood needed to be strong enough to withstand stress, but flexible enough to absorb shock. The earliest transport wheels were solid wood, simple discs made from planks joined and shaped. As civilizations advanced, wheels became more refined, incorporating separate spokes, rims, and hubs. It was likely in Sumer, one of the major city-states of Mesopotamia, that the first wheeled carts appeared. These carts were pulled by oxen and used to move goods across towns, farms, and trade routes. For the first time, heavy loads that would have required entire teams of people or animals could be transported by a single cart and a pair of beasts. This revolutionized agriculture, commerce, and military logistics. Archaeological evidence supports this narrative. Carved images and clay models from this period depict carts with wheels, and ancient tracks preserved in hardened mud show wear patterns consistent with rolling vehicles. Wheeled transport allows cities to grow larger, armies to mobilize faster, and trade to flourish. The wheel was not just a mechanical tool, it was a multiplier of civilization. One might ask, why Mesopotamia? Why did this invention not arise earlier or elsewhere? The answer lies in a convergence of conditions. Mesopotamia had the right resources: plentiful wood, animals suitable for domestication, and a terrain conducive to rolling transport. It had a growing urban population, with needs that could only be met through efficient movement. And it had the intellectual and technical environment to experiment, fail, and improve. Soon, the wheels spread beyond the boundaries of Mesopotamia. To the east, the Indus Valley civilization adopted wheeled carts for transport and trade. To the west, Egypt and the Levant began incorporating wheeled devices into their economies. The wheel was no longer a local innovation. It had become a global tool. The earliest wheels remained heavy and solid, limiting their speed and agility. But even in this basic form, they offered enormous advantages. Farmers could haul more crops to market. Builders could transport stones and timber with less effort. Governments could organize road-building projects and manage distant regions more effectively. The wheel had arrived, and with it came the dawn of an entirely new age. A circular idea had begun to turn the gears of progress, lifting humanity onto a path that would stretch far into the future. As the wheel spread outward from Mesopotamia, it found new life in the ancient civilizations of Egypt, the Indus Valley, and China. Each culture adapted the wheel to its own environment, needs, and innovations. The wheel was not a static tool. It evolved as it moved, absorbing the character of every civilization it touched. In ancient Egypt, the wheel arrived around 2000 BCE. The land of the Nile had long thrived without it. Egypt's transportation relied heavily on the river, which provided an efficient natural highway. But the arrival of the wheel introduced new possibilities. At first, Egyptians used solid wooden wheels, much like those seen in Mesopotamia. They were heavy and slow, but functional for moving stone and supplies. It was during Egypt's second intermediate period, when the Hyksos invaded from the Levant, that a major innovation arrived: the spoked wheel and the horse-drawn chariot. These chariots, lightweight and swift, revolutionized Egyptian warfare. For the first time, soldiers could fight from mobile platforms, launching arrows while in motion. The wheel had evolved from a tool of trade into a weapon of conquest. Egyptian chariots were feats of engineering. The wheels were lighter, made with 6 spokes, and the rims often reinforced with rawhide. Axles were moved to the rear of the chariot body to improve balance and handling. This allowed for faster turning and greater stability, critical advantages on the battlefield. These chariots became symbols of royal power and military prowess, frequently depicted in temple carvings and tomb paintings. Meanwhile, to the east, in the Indus Valley, modern-day Pakistan, and northwest India, the wheel was also taking root. The cities of Harappa and Mohenjo-Daro, among the most advanced urban centers of their time, show evidence of wheeled transport as early as 2500 BCE. Archaeologists have uncovered small clay models of carts, likely used by children as toys. But these miniatures reflect the real thing: solid wheeled carts, pulled by animals. The Indus civilization was characterized by well-planned streets, granaries, and drainage systems. Wheeled transport would have been crucial in supporting such infrastructure. Goods moved along straight roads, and farmers brought produce into market squares. The design of these early carts, with their fixed axles and simple construction, suited the flat terrain of the Indus Plains. Over time, innovations such as wider wheels for sandier roads and the use of copper or bronze linings to reduce friction appeared. In China, the wheel arrived somewhat later, but was quickly absorbed into a rich tradition of invention and mechanical curiosity. By 1500 BCE, the Chinese were already building wagons with wooden wheels. These were used in agriculture, transport, and eventually warfare. The Shang dynasty used wheeled chariots similar in concept to those of the Egyptians, and these became prominent in both battle and ceremony. But the real brilliance of Chinese innovation would come later. During the Han dynasty, wheelbarrows appeared, one of the most efficient single-person transport tools ever designed. The earliest wheelbarrows placed a single wheel at the center of a wooden frame, allowing one person to carry heavy loads with balance and ease. These were invaluable for construction, farming, and military supply chains. China also pioneered complex gear systems using wooden cogwheels and rotary motion in inventions such as the south-pointing chariot, a navigational device powered entirely by wheels and gears. This non-magnetic compass used differential gearing to maintain directional orientation regardless of the cart's turns. It was a mechanical marvel centuries ahead of its time. Throughout Asia and Africa, the wheel continued to adapt. In arid regions, wider wheels were developed to better distribute weight over sand. In mountainous areas, carts were narrowed for steep paths. Some cultures, such as the Nubians and other desert peoples, remained less reliant on wheels, using camels and pack animals instead. But wherever roads could be laid and wood could be worked, the wheel followed. By 1000 BCE, wheels in all their forms had become indispensable. From Egyptian chariots to Chinese wheelbarrows, the evolution of the wheel reflected not just technical skill, but cultural identity. Each new adaptation was a response to local needs, resources, and ingenuity. The wheel's journey across these early civilizations set the stage for even greater transformations to come. It had moved from pottery studios to the battlefield, from dusty roads to imperial highways. And as each society molded the wheel to its image, the wheel in turn molded society, shaping not only how people moved, but how they thought, traded, built, and conquered. The wheel's evolution from a functional tool to a strategic weapon reached a turning point with the advent of the chariot. It was in the crucible of war that the wheel demonstrated not only its utility, but its power to shape history. The chariot age, which began around 2000 BCE, saw this lightweight, horse-drawn vehicle become a game-changer across the ancient world. Chariots first appeared in the steppes of Central Asia, where Indo-European nomadic groups developed early versions to increase mobility. These chariots were marvels of engineering. They featured 2 wheels, each with 4 or 6 spokes, and a small platform just large enough for a driver and a warrior. Their key feature was speed. Unlike ox-drawn carts, which moved slowly over rough terrain, chariots were pulled by horses and could move swiftly over flat landscapes, giving armies an immense tactical advantage. The chariot was not merely a vehicle, it was a weaponized platform. Warriors riding chariots could fire arrows, throw spears, or wield swords while moving at high speeds. In battle, a well-deployed chariot force could disrupt enemy lines, chase down fleeing troops, or act as mobile archery units. As a result, empires across the Near East began investing in chariot forces, training horses and drivers, and constructing vast stables and chariot workshops. The Hittites, Egyptians, Assyrians, and Chinese all embraced the chariot. In Egypt, the reign of pharaohs like Thutmose III and Rameses II was defined by powerful chariot corps. The Battle of Kadesh, fought between the Egyptians and the Hittites around 1274 BCE, is one of the earliest well-documented chariot battles in history. Thousands of chariots clashed in a swirling, dusty spectacle, showing just how central the wheel had become to ancient military strategy. These vehicles pushed the limits of wheel design. To maximize speed and maneuverability, chariot wheels needed to be both light and durable. They were crafted from carefully selected woods, like elm or ash, with spokes precisely carved and steam-bent to fit into hubs and rims. Some rims were reinforced with leather or metal to reduce wear. The axles were greased with animal fat to ensure smooth rotation during long campaigns. Managing a chariot required more than strength. It required coordination. The driver had to control the horses, while the warrior maintained balance and aimed weapons. Elite charioteers trained for years, learning to maneuver their platforms with precision. In many cultures, driving a chariot was an honored skill, and charioteers held prestigious positions within armies and royal courts. In China, the Shang and Zhou dynasties developed chariots that mirrored their Western counterparts. Used in warfare, hunting, and ceremonial displays, Chinese chariots were status symbols as well as tactical assets. They were often buried with their owners in elaborate tombs, accompanied by horses and weaponry, a testament to the importance of the chariot in elite society. But as powerful as the chariot was, its era would not last forever. With time, changes in military technology and tactics began to erode its dominance. The rise of cavalry, individual horse-riding soldiers, offered even greater speed and flexibility. Infantry tactics adapted to counter chariot charges, and the development of rougher, less chariot-friendly terrain in warfare reduced their effectiveness. Still, the chariot left a profound legacy. It spurred innovations in metallurgy, wheel construction, and horse breeding. It linked distant cultures through trade in chariot parts and horse tack. It also inspired myths and legends, from the sun, god Helios, driving a fiery chariot across the sky, to the heroic tales of warriors racing into battle atop wheeled platforms. The chariot revolution was the first time the wheel served as more than a transporter. It became a force multiplier, a strategic asset, a symbol of prestige. And though its military use faded, the lessons learned in its construction and application would inform every future development in wheel-based transportation. By the end of the first millennium BCE, the chariot had largely disappeared from battlefields, but its influence was embedded in every axle that turned. The world had learned to harness speed, balance, and engineering in new ways, and the wheel had proven itself not just essential, but transformative. The rise of the Roman Empire brought with it an engineering renaissance, and at the heart of this transformation was the wheel. Unlike earlier civilizations, the Romans did not just adapt the wheel, they optimized it. Their legacy is not one of invention, but of standardization, expansion, and integration. The wheel became the backbone of the Roman economy, military, and society, working in tandem with one of their greatest achievements, the road. Roman roads were legendary. At their peak, the empire boasted over 400,000 kilometers of roads, with more than 80,000 kilometers paved in stone. These roads stretched from the misty hills of Britannia to the deserts of Syria. Built to endure, they featured layers of sand, gravel, stone slabs, and drainage ditches. Their purpose was simple but ambitious: to move people, goods, and information quickly across vast territories. And the wheel was the perfect partner. Roman carts and wagons varied in size and function. The plostrum was a heavy-duty ox-drawn cart used for transporting goods like grain, timber, and stone. The carus, a lighter, two-wheeled vehicle, was faster and more maneuverable, often pulled by horses. For passengers, there were the carpentum, a covered, elegant carriage used by the elite, and the cisium, a fast, open two-wheeler favored by couriers. All these vehicles relied on wooden wheels, reinforced with iron bands. The iron not only protected the wood from wear, but also improved grip on stone roads. The axle and hub systems were precisely crafted, often lubricated with animal fats to reduce friction. Rome's blacksmiths and carpenters formed guilds to maintain high standards in wheel and cart production. To support wheeled transport, Rome established a logistical network called the Cursus Publicus, a state-run courier and transportation service. Relay stations, known as mutationes, provided fresh horses and vehicle repairs, while mansiones offered food and lodging for travelers. This system allowed officials, messengers, and military orders to travel swiftly and efficiently throughout the empire. One of the most impactful aspects of Roman transport was regulation. The width of Roman chariot ruts, typically about 4 feet 8.5 inches, became a de facto standard. This width would later influence the design of railway tracks thousands of years later, demonstrating the enduring impact of Roman engineering choices. The wheel also played a major role in Roman industry. Mill wheels, both vertical and horizontal, were used to grind grain at large watermills, such as those found in Barbegal, France. The Barbegal mills, in particular, were an industrial marvel. 16 water wheels arranged in parallel rows, capable of grinding enough flour to feed thousands. These mills represent one of the earliest examples of mass production powered by wheel-based technology. In cities, wheeled traffic was both a necessity and a nuisance. Streets in Rome became so congested with wagons during the day that Emperor Julius Caesar passed laws restricting cart movement to nighttime hours. This nighttime traffic filled the streets with noise, leading Roman writers like Juvenal to complain that sleep was impossible for city dwellers. Despite the challenges, the Romans understood the value of wheeled transport in maintaining their empire. Roads and wheels allowed soldiers to march quickly to distant fronts, farmers to bring produce to market, and merchants to deliver goods from all corners of the known world. Wine from Gaul, olive oil from Hispania, and marble from Greece, all moved by wheel. Roman theatres and circuses even showcased the wheel for entertainment. Chariot races at the Circus Maximus drew crowds of tens of thousands. Teams competed for glory, wealth, and political favor, and drivers, many of whom were slaves or freedmen, became celebrities. The speed and danger of these races captured the imagination of the public and emphasized the wheel's cultural as well as practical importance. When the Western Roman Empire fell in the 5th century CE, much of its road network fell into disrepair, but the concept of the wheel as a unifying force, economically, militarily, and culturally, had been firmly established. Later, empires and kingdoms would inherit this knowledge, using it to rebuild and expand. Rome didn't invent the wheel, but it proved that when paired with vision and infrastructure, the wheel could do more than carry a load. It could carry a civilization. In Rome, the wheel was not just a tool, it was a system. And that system, built with remarkable foresight, continues to influence the modern world to this day. The fall of the Western Roman Empire in the 5th century CE marked the beginning of the medieval period in Europe, a time often described as the Dark Ages. Yet, even in an age of political fragmentation and slow recovery, the wheel did not disappear. It adapted to new needs and challenges, becoming a quiet force that shaped the medieval world from farms to monasteries. One of the most enduring uses of the wheel in the medieval period was in the form of the wagon. With the Roman roads deteriorating, travel became more difficult, but wheeled carts remained indispensable in rural and urban life alike. Farmers used them to transport hay, firewood, grain, and tools. Markets bustled with carts pulled by oxen, and townsfolk hauled barrels of ale and baskets of goods through narrow, winding streets. The design of the medieval wagon was functional and robust. Wheels were still made of wood, often with iron bands for durability. Axles were usually fixed, and steering was rudimentary. Carts were often dragged rather than turned with precision. In heavily forested regions, sledges sometimes replaced wheels altogether, especially in winter months, when snow and mud made rolling impractical. But the most dramatic evolution of the wheel in this era came not on roads, but in the water and wind. The medieval world saw the rise of water wheels and windmills, two technologies that harnessed natural forces and turned them into mechanical power. Water wheels had been used in antiquity, but in the medieval period they were refined and widely adopted. Vertical water wheels, driven by rivers or streams, powered mills that ground grain, crushed seeds, and even hammered metal in forges. Monasteries and feudal estates often built these mills as a way to process food and goods more efficiently. There were several types of water wheels in use. The undershot wheel, which relied on fast-moving streams to turn paddles. The overshot wheel, where water fell from above to generate more torque. And the breastshot wheel, which received water halfway up the structure. Each type was suited to different terrains and stream conditions. Some mills combined multiple wheels for increased output, marking an early form of industrial scaling. Windmills emerged slightly later, first appearing in Persia around the 9th century and spreading to Europe by the 12th century. In areas lacking flowing water, windmills offered an alternative source of mechanical energy. Their large, sail-like vanes caught the wind and transferred motion through a system of gears and shafts to grind grain or pump water. The Dutch, in particular, became masters of windmill engineering. By the late Middle Ages, they had developed windmills capable of draining marshland, making arable land out of swamps. These towering wooden structures became not only vital agricultural tools, but cultural icons, symbols of ingenuity and persistence against the forces of nature. Medieval Europe also saw the wheel at work in the burgeoning trade economy. Merchant wagons traveled along trade routes like the Silk Road and the Hanseatic League corridors. Wheels enabled the flow of cloth, spices, furs, and books across great distances, connecting distant markets and cultures. In towns, wheelwrights became essential craftsmen, and their skills were passed down through guilds and apprenticeships. Even within cities, the wheel was ever present. Turnspits, a kind of small rotary spit for cooking, used wheels powered by dogs or gravity to rotate meat over fire. Cathedrals under construction used massive treadwheel cranes, human-powered hamster wheels that lifted heavy stones into place. These applications reveal the creativity with which people adapted the wheel to solve complex physical challenges. The medieval period also reawakened curiosity about science and mechanics. As texts from the ancient world were translated and preserved, interest in gears, levers, and rotational motion grew. Thinkers like Villard de Honnecourt sketched mechanical diagrams featuring gear trains and escapement wheels, foreshadowing the renaissance of engineering that would come in later centuries. The wheel, though humble in appearance, remained a cornerstone of progress. It moved food, powered machines, supported construction, and bridged the gap between manual labor and mechanization. In a world rebuilding itself from the ruins of Rome, the wheel was more than a tool. It was a quiet revolution, turning steadily toward a brighter, more connected future. As Europe emerged from the medieval era and entered the Renaissance, a new spirit of curiosity and invention began to flourish. Humanity was rediscovering the wisdom of the ancient world, and in that rediscovery, the wheel once again gained prominence, this time as part of a growing web of mechanical innovation. The Renaissance to the Industrial Age was not just a time of philosophical revival, but a period when wheels, gears, and machines began to redefine the very nature of work, speed, and production. The Renaissance saw thinkers, artists, and engineers turning their attention to the mechanisms behind motion. One of the most famous figures of this era, Leonardo da Vinci, filled his notebooks with drawings of gear systems, treadmills, rotating bridges, and self-propelled carts. While many of his designs remained theoretical, they represented a shift, an understanding that wheels and gears could be used not just for transport, but for transformation. The wheel began to appear in new roles. Clocks, for instance, emerged as symbols of precision and intellect. These intricate devices relied on finely tuned gear trains powered by weights or springs. Each gear turned another in a carefully calculated rhythm, allowing time to be measured in minutes and seconds. Towns across Europe began installing large clock towers, not just as public utilities, but as symbols of civic pride and technological advancement. Meanwhile, the printing press, one of the most influential inventions of the modern world, also relied on wheels. Johannes Gutenberg's movable type press, developed around 1440, used a screw mechanism to press inked letters onto paper, making books cheaper and more accessible. Though it wasn't a wheel in the traditional sense, it utilized rotary motion and mechanical advantage, principles that would dominate the coming industrial era. By the 17th century, advancements in metallurgy and tool-making allowed for even more precise mechanical components. This led to the development of gear-driven astronomical models, wind-powered mechanical dolls, and early scientific instruments, all powered by rotary motion. The wheel, whether in the form of a pulley, flywheel, or cog, had become a universal mechanism of ingenuity. And then came the Industrial Revolution. Beginning in the late 18th century in Britain, the Industrial Revolution represented a monumental shift in how societies produced goods and consumed energy. It was a revolution built on wheels, specifically wheels connected by belts, gears, and pistons in massive smoke-belching machines. Factories replaced workshops, and human labor was increasingly supplemented or replaced by the power of steam. At the heart of this change was the steam engine. Inventors like James Watt refined early steam engines, using rotary wheels to convert reciprocating motion into continuous turning force. Flywheels were essential to this process, maintaining momentum and regulating speed in machines that would otherwise move erratically. Factories buzzed with looms, presses, and hammers, all synchronized by rotating wheels and powered by steam. One of the earliest and most iconic examples was the spinning jenny, developed by James Hargreaves in 1764. This multi-spindle spinning frame allowed a single worker to spin multiple threads at once, vastly increasing textile production. Its wheels and spindles became symbols of the mechanization of labor. The wheel also revolutionized transportation during this period. In the early 1800s, George Stephenson developed the first practical steam locomotive. Iron wheels riding on iron rails allowed for the movement of massive loads over long distances at unprecedented speeds. Railroads soon crisscrossed Europe and North America, powered by pistons and rotary wheels, converting steam into movement. The width of railway tracks, based, interestingly, on the dimensions of Roman cart ruts, reflected a continuity of design that had lasted millennia. Even the ship was transformed by the wheel. Paddle steamers replaced sailboats on rivers and coastlines. Giant wheels turned on either side of these vessels, churning through water with a rhythm that matched the pulse of the industrial world. These ships opened new frontiers for commerce and communication. As the century progressed, factories and foundries continued to innovate. Assembly lines, pioneered in part by figures like Eli Whitney and later perfected by Henry Ford, relied on conveyor belts, pulleys, and wheels to move products efficiently from one station to the next. Wheels no longer served just as carriers of goods or passengers. They became central components of production itself. Wheels also made their way into domestic life. The sewing machine, invented in the 19th century, used foot-powered treadles to turn wheels and drive needles with precision. Kitchen appliances, hand drills, and even early bicycles brought rotary motion into the everyday experience of millions. By the dawn of the 20th century, wheels had become so ubiquitous that they were practically invisible. But their influence was everywhere, in the ticking of a clock, the rumble of a train, the whir of a textile loom, or the hiss of a steam pipe. They powered cities, transformed labor, and connected continents. The industrial age did not just harness the power of coal or steam, it harnessed the momentum of the wheel. What began as a tool to carry goods over muddy ground had become a symbol of progress itself, rotating, spinning, turning ever forward. In factories and locomotives, in gears and axles, in pulleys and presses, the wheel had come of age. It had become the engine of civilization. By the dawn of the 20th century, the wheel had already revolutionized human civilization multiple times, but its greatest leap, its transformation into a central element of modern life, was still ahead. In this new era, the wheel would become not just a tool or mechanism, but the defining feature of entire industries, infrastructures, and lifestyles. Perhaps no invention better illustrates this transformation than the automobile. Though many inventors experimented with self-propelled vehicles in the 18th and 19th centuries, it was Carl Benz's 1885 motor wagon that marked the birth of the modern car. Powered by a gasoline engine, mounted on 3 wire-spoked wheels, and controlled by a tiller, it represented a major step in wheel-based transport. But it was Henry Ford who would bring the car to the masses. In 1908, Ford introduced the Model T, an affordable, durable automobile designed for the average worker. Its success was built on a network of wheels, rubber-tired road wheels, steering gears, transmission systems, and conveyor belts in the assembly line that built it. By integrating the wheel into both the product and the process, Ford transformed manufacturing and society itself. The car reshaped cities and lives. Streets were paved and widened. Suburbs grew. People gained unprecedented freedom of movement. And the wheel was central to it all, rotating tirelessly beneath every journey, carrying families, workers, goods, and dreams across the asphalt arteries of the world. Meanwhile, trains, born during the Industrial Revolution, reached new heights in the 20th century. Steam engines gave way to diesel and electric locomotives. Tracks expanded, connecting urban centers to rural towns, nations to their neighbors, continents to global markets. Train wheels, forged from hardened steel and engineered for precision, ran on carefully spaced rails, an elegant system of low friction and high efficiency. High-speed rail emerged in Japan with the Shinkansen in the 1960s, followed by France's TGV and other systems around the globe. Traveling at speeds of 300 kilometers per hour and more, these trains relied on advanced wheel and rail dynamics, shock-absorbing suspensions, and aerodynamic designs. The wheel, now refined to an art form, was enabling near flight on land. Speaking of flight, the wheel took to the skies as well. Though airplanes fly through the air, they depend on wheels for takeoff, landing, and ground movement. Early planes like the Wright Flyer had simple wooden wheels mounted on skids. As aviation evolved, retractable landing gear with hydraulic wheel systems became standard. Airplane wheels are some of the most advanced ever built. They must withstand enormous pressure and speed during landing, often touching down at over 150 miles per hour, while bearing tons of weight. They use high-pressure tires, anti-skid braking systems, and heat-resistant materials. Each component is tested to extremes, yet the principle remains unchanged: rotation enabling motion. Beyond personal and commercial travel, the 20th century also saw the wheel embedded in military and industrial applications. Tanks, armored personnel carriers, jeeps, and trucks, all wheeled or tracked vehicles, became critical in modern warfare. On the home front, forklifts, tractors, and harvesters transformed agriculture and logistics. The bicycle, too, flourished. Though invented in the 19th century, it became a symbol of health, freedom, and environmental consciousness in the modern age. Its design, 2 wheels, pedals, gears, and a lightweight frame, epitomized mechanical efficiency. Millions ride them every day, relying on rubber tires and spinning spokes to carry them through cities and countryside. Urban design increasingly accommodated wheels. Bike lanes, highways, roller rinks, skate parks, even wheelchairs became more refined, enabling mobility for millions of people with disabilities. The wheel was no longer a novelty. It was an extension of human motion. The digital age introduced new forms of wheel technology. Robotics began using wheels for navigation. Automated vacuum cleaners, warehouse shuttles, and planetary rovers all relied on various forms of wheels, from treads and omni-wheels to articulated suspension systems. The Mars rover's Spirit, Opportunity, and Curiosity rolled over alien soil, extending the reach of the wheel beyond Earth. Meanwhile, in homes and offices, wheels showed up in subtle ways, on suitcases, desk chairs, conveyor systems, and camera sliders. Though they rarely drew attention, they enabled motion, saved labor, and quietly shaped the modern environment. The invention of synthetic materials, such as nylon and polyurethane, expanded wheel design. Skateboards and rollerblades gained smoother rides. Factory carts became lighter and quieter. Wheel designs diversified, some with integrated motors, some with smart sensors, some designed to function in zero gravity. Through all of this, one truth remained: the wheel endured because it was adaptable. Whether carved from stone, forged in steel, or molded in plastic, its elegant principle of circular motion remained central to our progress. The 20th century did not make the wheel obsolete. It made the wheel invisible, embedded in every machine, vehicle, and space of modern life. As we entered the 21st century, the wheel was ready to evolve again. But before looking ahead, it's worth marveling at the journey so far, a story of invention and reinvention, of rotation and revolution, of a shape that never stops turning. As we stepped into the 21st century, the wheel continued its quiet but profound evolution. Though much of the attention in the digital age turned toward invisible forces, electrons, data, and wireless communication, the physical world remained full of motion. And that motion, more often than not, was still powered by wheels. In robotics, for instance, the wheel is foundational. Whether in factories, hospitals, homes, or outer space, wheeled robots provide efficient and reliable mobility. Warehouse robots, designed by companies like Amazon, zip along polished floors, guided by QR codes and sensors, delivering packages with speed and accuracy. Service robots in airports and hospitals use omnidirectional wheels to maneuver in tight spaces, mimicking the grace of a human pivot. The wheel also plays a central role in exploration beyond Earth. Mars rovers such as Spirit, Opportunity, Curiosity, and Perseverance are equipped with specially designed wheels that handle rocky terrain, dust, and extreme temperatures. These robotic explorers have used their wheels not just to move, but to drill, dig, and discover. Through them, the wheel has left its tracks on a distant world. In consumer electronics, wheels show up in subtle yet significant forms. Scroll wheels on computer mice, jog wheels on audio equipment, and rotary encoders in touch-sensitive devices demonstrate that even in a digital world, physical rotation still provides intuitive control. The original Apple iPod, with its iconic click wheel, exemplified how the old could be made new again. Transportation has also seen the wheel evolve with technology. Electric scooters and bikes populate urban streets, offering efficient and eco-friendly alternatives to cars. Electric cars, powered by motors directly linked to their wheels, redefine how torque and traction are managed. Regenerative braking systems allow these wheels to convert kinetic energy back into electricity. In gaming and simulation, force feedback steering wheels create realistic driving experiences, while exercise bikes with digital resistance wheels merge fitness with entertainment. The blending of virtual and physical realms increasingly depends on precise mechanical components, most of them still rotating wheels. Artificial intelligence and machine learning have enabled smarter wheel-based systems. Autonomous delivery bots roll across campuses and cities, while advanced prosthetics use rotating joints to give amputees fluid, lifelike motion. Even the field of rehabilitation has embraced wheeled robotics, with exoskeletons and support chairs restoring mobility to those who lost it. Perhaps most symbolically, the wheel continues to represent continuity and renewal. In design, it remains a favorite metaphor, used in logos, architecture, and user interfaces to suggest cycles, systems, and connection. Though it may no longer draw gasps of wonder, the wheel is more powerful than ever. It has become integrated into the architecture of modern life, from industrial automation to planetary exploration. In the digital age, the wheel is still spinning, smarter, subtler, but always turning. The story of the wheel is a story of humanity itself, from stone rollers dragged across ancient soil to space-age alloys rolling on distant planets. The wheel has been with us, silent, constant, indispensable. It began with necessity, shaped by curiosity, and matured through ingenuity. The first potter's wheel turned clay into vessels. The first cart carried more than one person could bear. The first chariot changed the course of wars. The wheel was always more than an object. It was an enabler of movement, of speed, of change. And its shape, simple, symmetrical, complete, became symbolic. It came to represent cycles of time, the turning of seasons, the rise and fall of civilizations. Religions and philosophies adopted it. The Dharma wheel in Buddhism, the wheel of fortune in medieval law, the circular mandalas of mysticism and meditation. The Industrial Revolution saw the wheel take center stage. It spun looms, drove engines, and formed the pulsing heart of every factory. And even as digital technology grew more abstract, the wheel never left. It simply adapted, found new forms, and spun its way into code, robotics, and imagination. Today, we may not always notice it. It hides inside our homes, behind screens, beneath vehicles, inside satellites. Yet it still does what it always did. It carries us. It brings us closer, to each other, to our past, to our future. It turns beneath the weight of our world, bearing us forward. The wheel reminds us that even the simplest ideas can carry infinite potential. That motion is the path to progress, and that sometimes the most revolutionary thing is not to reinvent the world, but to keep it turning.